Welcome to our paper Ensuring Consistency for Asynchronous Group Key Management in the Industrial Internet of Things.
I am Alessandro Piccoli.
And I am Marc-Oliver Pahl, and we'll present to you our work. This is the structure, but you'll see it more in detail in the presentation. And this is our setting. So the Industrial Internet of Things is basically everywhere. We have it in our water distribution, we have it in our power distribution, transportation, and so on. Special thing about the Industrial Internet of Things is that formally separate entities get connected, plus they're connected to the internet. And this creates a big attack surface. For our research, we chose smart grids, and in there, the substations that control the distribution of the energy locally. We chose this because it's a highly standardized environment, and the protocol that is used has a significant flaw that can lead to these substations not being able to communicate anymore because they don't have the common group key. The protocol that is used there is the Group Domain of Interpretation, GDOI, and Alessandro will tell us more details about how this protocol is working and which are the operation modes of it.
The Group Domain of Interpretation is commonly deployed already in this setting. It is a centralized protocol, so it respects the architecture of a substation with a group controller and several group members. GDOI is a protocol for key distribution and key management. After an initial phase 1 for the authentication of the group members to the group controller, there is the actual key distribution and management. Two modes are specified in the RFC 6407. The first one is synchronous and is based on a push operation for distributing the keys. The second one is asynchronous and is based on a pull operation for the distribution and management of the keys. In the standardization, there is a tendency to use the asynchronous mode for its resource advantages. However, in order not to overload the server with requests, the pull key updates are spread in a window of time. This, of course, creates a consistency problem because if a member pulls its key at the beginning, then it already has the new key, and the member that pulls its key at the end will have its key a few seconds later. This creates a consistency problem for which there is no solution right now. And if there is a connection error or any kind of problem, then the group member would have to issue a pull request again in order to update its key. Of course, this can create some consistency problems. We present our solution for this.
The reason why the pull operation is the one that is chosen for the Industrial Internet of Things often is also that the devices might be in sleep mode and then they are not awake when there's a push from the central entities that you see in the center. And the consistency problem is then that when you don't have the shared key and you have a message over a multicast channel, then obviously you cannot decrypt it.
As we said, the synchronous operation provides consistency, but it doesn't fit the resource limitations of substation devices. On the other hand, the asynchronous mode provides no consistency mechanism, but it fits and therefore is used in substation automation. Our goal in this presentation is to show you a solution for a consistent asynchronous key update procedure in constrained environments, considering the requirements of our specific target scenario. We can see the related work for this kind of problem. We identified several group key management protocols that provide solutions for the several requirements we identified for our scenario, but none of them presents a fully comprehensive solution for our problem.
Plus, they're also not part of the standard for the substation automations.
Yeah, exactly. And in particular, we identified an asynchronous mechanism that ensures consistency via confirmation messages. However, this architecture cannot be fully applied to our scenario because the algorithm that is used, the protocol that is used, is based on a decentralized architecture.
Here we see the normal decentralized asynchronous mechanism. So we see on the right side the group controller, the key distribution center, and we see the different members asynchronously pulling the new key. And what is new now, Alessandro?
First of all, you can see very clearly what the problem is. The first member updates its key at a certain point in time, the last member at another point in time, and what happens what key are they using in that window of time could lead to a problem. So in order to ensure consistency for this highly critical infrastructure, we decided to introduce one additional message exchanged among the group members when the key update procedure is completed. How do the group members know when the key update procedure is complete? Well, the group controller, who has knowledge of the group membership, keeps track of the various key updates incoming from the group members. When the last group member pulls its new key, then the group controller will attach to the last message of the pull procedure one additional payload, including the so-called key delivery assurance. When the last member receives the key delivery assurance, it can just dispatch this payload over the multicast channel to all the other group members. In this way, when they all receive this additional payload, they know that the key update procedure is complete and they can now switch securely to the new credentials.
Very good. And so the questions obviously are, is the protocol secure and what is the overhead? And you looked at both of them. So the formal evaluation said that it's secure. And what did the quantitative evaluation say?
The quantitative evaluation said that the latency of the protocol does not increase despite the increasing number of sessions. We tested this over 5 clients and 1 key distribution centers, and it was confirmed via multiple test runs.
As you can also see on the right. And yeah, so conclusion, a nice extension that can also be useful for other domains with resource constrained devices. And here are our references, and thank you for the attention. We are looking forward to your questions.